Using this TIA portal, we can configure 1200 PLCs, 1500 PLCs. We have some PLCs we have also 300 PLCs, limited 300 PLCs which can be configured, which is older devices. For latest, we have 1200 PLC and 1500 PLC. In TIA portal, we have some versions, which I mean from TIA portal 18, TIA portal V18, V19, V20. Here this version difference Y means new. If any new PLC is introduced by the Siemens, then they will release a new TIA portal, a new update to the existing TIA portal. In that the PLC can be included using that. If any new PLC is added for that particular TIA portal or particular model, we have an HSB file, hardware supporting file, so that we can install existing TIA portal also, so that the same module can be installed within which we have also. Rather to update, we can also use that TIA portal and we can configure that. Core engineering areas. Why TIA portal is used and how it is used for the engineering means mainly for hardware configuration. To write a logic, to execute a logic or anything, we need to do first hardware configuration. Without any hardware configuration, the PLC can't get the addresses of the inputs and the addresses of the outputs. This is the hardware configuration we will show using a sample, not sample project. We will take some cards as from our system, we will configure it, and we will show how to configure, how to add, how to search easy way, and how to communicate with the PLC. Next to most thing is PLC programming. Here PLC programming, we have added some. This is an example which we have done. This is a 1500 PLC. Even this is also a different type of 1500 PLC. This is 1543 1511 PLC. Here 1515. Here we have some folders where we can see that software units, program blocks, technology blocks, energy blocks, external sources, like that. Here we may mostly use device configuration, so that we can assign the IP here. I will show how to assign the IP after this PPT or afternoon. Here we can in device configuration we can assign some minimum parameters so that PLC can act and can address everything for the from the IO card. Here we have program blocks, main blocks, functional blocks. Functions we have FB blocks and FC blocks. I will show the differences also, and we have DBs, data blocks, where we can store the data. And this is the technology blocks where we use for that. I have told that motion controls which use for servo motors, which can be controlled 3 axes such as XYZ, XYZ axis machines, so that the machine can be configured and can be run in a particular manner, particular distance, and particular speed also. So in that, the technology blocks it will give us a configuration to communicate how we can. This is also a configuration how we are configuration in these cards, same as we can configuration for servo drives. For that we can use technology blocks. Here externals, here energy, it introduced more in Siemens by Siemens also. Here external source files. I mean any type of files such as I say any FB block which is we have already in higher version. Suppose this is a V18 version. We have developed in V20 version. Upgradation can be possible. Downgradation can't be possible in TIA portal. For that we can export if it is in V20 or any above TIA portal, we can right click on that, so we can export that SCL format file. SCL format, if when we add here, the same block can be comes in program block. same input, same output. Further to next year PLC tags, where we can see all type of tags, which means digital input card, digital output card, analog output, analog input, and local load memories, global memories can be checked, can be seen in PLC. All type of tags can be used. PLC data types here. PLC data, if a data type means there is a motor. In motor, we take running status feedback, trip feedback, sorry, on feedback, trip feedback, on command. So this is three can be used multiple times. So rather than in DB, we use motor start, motor stop, motor like that. In digital data PLC data types, we create a standard data type, so that it if we call in DB, we just type a name. Here we can assign a flexible name. In DB we can give motor 1, motor 2 like that. That is also different. If you want to give such as this is a VFD motor, this is a DOR motor. For that for two we have same feedbacks and same outputs for that. For that, sir, here I can give VFD motor and give as a data type as a which I have created here, PLC data type. Same inputs and same outputs can be come in that, sir. Rather to create multiple three tags, we can create only one tag, so it will come with three tags. I will show that example afternoon, sir. Next, sir, we have watch and force table, where we can uh, check the inputs or outputs are active or not. For that we can unforce the inputs, so that without connecting in any hardware, we can connect to the sorry, without connecting in any hardware, there is no physical input. So if we force that, upon that PLC will lag. I mean, if I 0.0, it is a push button. According to that push button, we executed a logic, we written a logic, and the PLC will be execute that logic cell. For suppose the push button, we don't have any provision to act on that provision. Simply we can force in force table, we can add the tag name or tag address, so that it will give us the details, the status of the tag, and how to force it. We will show that by forcing that input, but by visually the PLC gets that it the card has got 24 volts, so it will be triggered from 0 to 1. Here, sir, we have OPC UA communication. If we want OPC UA communication, we need to configure here, sir. It is acted same like as Modbus which is there, no, sir. Which at OPC UA also just used for data communication, data transfers. But it is that Modbus can be connected to the devices or anything, but OPC UA is connected to the servers.